Today on How It's Made Dream Cars, the Pagani Huayra, a luxury GT inspired by the Aymara god of wind. Inside the Pagani headquarters in Modena, Italy, the company museum showcases the work of Horacio Pagani, such as the Zonda Revolution, a supercar with race car features built for track only. Pagani already dreamt of building his own supercar when he came to Italy at age 27. His first prototypes, carved in Argentinian balsa wood blocks back in the mid-1960s, were inspired by Bertoni and Giugiaro designs. Pagani made this mini motocross when he was only 15. He later designed and built this Argentinian F3 powered by Renault and equipped with a drag reduction system and a side air intake. The Huayra is a result of Pagani's long experience with composite materials and aerodynamic design. Pagani is the only car manufacturer to use a carbon fiber and titanium alloy. Thanks to its carbotanium chassis, the Huayra weighs less than 3,000 pounds. At the company's styling center, designers work on individual designs for each new car produced. One designer meets with Horacio Pagani at the main desk. They discuss the features and characteristics of the car's design, which have been thoroughly studied on scale models. Small adjustments in the lines and shape of the design sketches from one model to the next have led to the final design. Styling for every model is customized and personalized, tailored as a suit. Acting as chief designer, Pagani supervises the styling of each model and discusses all choices with the designers. The wing shape design of the car is not only fashionable, it's the fundamental aerodynamic principle behind the supercar that gives the vehicle its distinctive shape and style. An operator takes carbon fiber rolls from a CNC cutter, which automatically shapes all the necessary pieces to mold the various parts of the chassis. The operator detaches the carbon fiber pieces, which make all 240 different parts of the car's internal and external body. The carbon fiber steering wheel weighs only 1.5 pounds. Being up to 6.5 times lighter than steel, carbotitanium has the best weight-strength ratio in the automotive industry. This carbon fiber sandwich makes a bullet and fireproof protection for the fuel tank. Like the steering wheel, all chassis parts are molded as one piece of carbon fiber. Workers place raw carbotitanium on a mold. They remove the backside plastic membrane, protecting the resin adhesive of the pre-preg cloth, and position it on the mold. They press it in place, first using their fingertips, then with a carbon fiber tool to remove air bubbles and wrinkles. One worker heats the blade of his cutter to trim off the excess carbon fiber cloth and remove it from the mold. For big pieces such as this door, there are always two operators working together. The work calls for fine precision and a key eye for details. Workers cover the carbon fiber cloth with the surfacing fabric before wrapping it in a vacuum bag. They install a vacuum fitting valve to create a sealed joint between the bag and the vacuum tubing. A pump sucks the air out of the bag to create a vacuum, which protects the carbon fiber during the cooking process. They place the mold in an autoclave oven, an industrial pressure vessel used to process composite materials such as carbon fiber. It works as a giant pressure cooker, which submits the material to high pressure and intense heat behind a massive door. The door shuts hermetically before the pressure and heat start building up to shape the carbon fiber part. The formed parts are unmolded in another facility inside negative pressure cabins, where air, temperature, and humidity are monitored. A worker grinds off sharp ridges left from the molding process. He smooths and polishes the edges and adjusts the ledges, one small segment at a time. Unlike in most automotive production facilities, these operations involve small precision hand tools rather than large CNC robots. The quadruple exhaust system is a trademark of Pagani car designs. Made of 22 pounds of pure titanium, it's built in Germany and customized for the Huayra. The mufflers are tuned to sound like an airplane taking off. A worker folds titanium sheets to make exhaust pipes using a manually adjusted roller press. He feeds the sheet into the press and runs it through once. He then locks the sheet back in the press feeder, manually tightens the roller, and runs it through again to form it into a tube. The titanium used to make these pipes makes the exhaust resistant to strain and plastic deformation. Another worker places a tube in a clamp and tightens it. He inserts a filler rod, positions the welder head over the tube, and starts welding, using a beam laser welder to make a fine and narrow weld. He closes the ends of the welding seam with a hammer. A technician inserts a pipe in the tube bending machine and fits a holding rod into its opening. The machine bends the tube at a 25-degree angle. Titanium is an incredibly ductile material, which can bend without breaking. A worker inserts a titanium tube in the die of a large hydroforming tool, which will shape the muffler. Hydroforming uses a high-pressure hydraulic fluid to press the titanium into the die. The machine applies over 8,700 psi of pressure, equivalent to the pressure of the Pacific Ocean's floor. The worker removes the tube, now formed with its characteristic elliptical shape. A worker installs the cut and polished muffler on a stand and puts the piece into an oven. He closes the door and leaves the titanium to cook for 1 hour at a temperature that is kept secret. Titanium reacts to heat by oxidizing, forming a thin and transparent oxide layer, which gives the metal a bright purple appearance. Once the metal cools down, a worker applies stencil glue on the oxidized metal surface. He sandblasts the stencil with compressed air, charged with non-oxidized titanium particles. This makes the brand and model name stand out on the muffler. All welds on the muffler are done by hand. Precision is key, both at the structural level and for the visual aspect. The exhaust system is now assembled with 2 catalytic converters. Aluminum parts of the Huayra are machined by Aspa in Italy before they are shipped to the Mercedes-AMG plant. The air intake is one of over 1,000 CNC machined parts. It's carved like a sculpture in one single block of aluminum in a process that lasts 24 hours. The finished anodized piece is sent to the AMG plant in Huayra, Germany, where the engine is assembled. A mechanic inserts the crankshaft in the crankcase using an overhead hoist to position the axle on pre-oiled bearings. He installs gears for the timing chain before closing the crankcase. Holding the connecting rod in one hand, he applies a generous coat of oil on a high-strength, lightweight piston. He inserts it in the pre-assembled short block using a matrix to slide the piston into the cylinder. He turns the engine block around and applies oil on the crankshaft. He fastens the connecting rods on the crankshaft, installing 2 sets of 6 pistons at a 60-degree angle in a twin-turbo V12 configuration. The mechanic manually cranks the shaft to test the responsiveness of the crankshaft, connecting rods, and pistons. He installs the timing chain and the iron oil pan. The timing chain has very specific lubrication requirements, which only an exclusive high-performance oil can meet. The car uses a chain rather than a belt because it is much more reliable and durable. The mechanic installs cylinder heads equipped with a 3-valve distribution camshaft, which optimizes the engine's performance. He installs a camshaft cover with a golden cap designed to match the Aspa air intake. He installs the exhaust manifold and turbocharger intake system, assembled close together to reduce the turbo lag. The massive engine is ready for the final assembly step. The mechanic installs the air intake and connects it to cylinder heads, designed to provide the engine with the best possible throttle. He places the intercooler's bracket on top of the air intake and adds on the customized mechanic's signature plate. According to AMG's one-man, one-engine policy, each mechanic leaves his own personal signature on every car engine he assembles. A technician monitors engine testing from a control room. A dynamometer controls the torque and power of the engine, which are respectively measured in Newton meters and kilowatts. The engine runs at full speed to test the turbo intakes and exhaust manifolds. The dyno also monitors fuel consumption and CO2 emissions of the engine, running at lower speed and idling in neutral gear. At the assembly line in Modena, Italy, leather seats for the Pagani Huayra are produced by Dani Leather's automotive division. They combine the design and quality of high-end fashion leather with the resistance of automotive leather. Near Vicenza in northern Italy, cold-fleshed cowhides arrive at the leather tannery. Workers cure the hides using coarse salt to absorb moisture in the skins. A crane operator puts the cured hides in a drum to shake off the salt before the tanning process begins. A loader throws the hides into a big liming drum used for soaking and unhairing. This process rehydrates and swells up the skins, chemically dissolves the hair, and opens up the fiber structure of the leather. The loader brings the raw hides to the fleshing machine. Fleshing consists of removing excess natural fibers or grease from the hides and cutting off any muscle or fat still attached to the skin. The fleshed hides transfer on a suspended conveyor to the splitting section. The pelt splitting machine separates the top grain leather from the bottom layer called split. The machine also shaves the hides, adjusting their thickness to the millimeter. Each fleshed, split, and shaved hide stops for a quality inspection check before the next step of the tanning process. The hides soak in water mixed with dissolved sodium chloride. The tanning drum door closes before a machine pumps tanning salts and tanning auxiliaries into the turning drum. A chemical reaction occurs in the tanning process, transforming the raw hides into this wet blue fabric. Workers lay out the hides on a stainless steel table and flatten them with rulers to remove wrinkles. Once the skins are flat, the plate moves upwards and heats up the fabric for the vacuum drying process, which removes the remaining moisture. Coupled vacuum and vapor compression suck the humidity out of the hides. To finalize the drying process, the skins hang to dry at room temperature, exposed to air. A rotary spray applies a thin coat of paint on the external layer of the hides. It sprays through high-pressure nozzles, similar to automotive paint guns. These finished full-grain hides show the natural grain pattern of top-quality leather. Workers lay out the full hide flat on a cutting table and get ready to dress up the seat. A tailor lines out the areas with slight imperfections in chalk to keep only the top-grade leather for the seat upholstery. He takes a template and selects a segment of the hide to make the piece. He places a weight on top of the template to keep it from moving while he traces the cut line with a fine white pencil. Each part is tailored for a different end use. The steering wheel, dashboard, panels, and gear stick covers. The head and armrests, or in this case, the seats. The tailor carefully cuts the piece using fine precision scissors to shape the leather garment down to the finest details. A worker stitches the parts together using an industrial leather sewing machine. Automotive sector sewing requires high-quality threads that are both robust and durable. The thread's resistance to scuffing and high temperature is about as important as the quality of the stitches and the overall finish of the sewing. A carbon fiber skeleton, padded with premium automotive open-cell polyurethane foam, hides underneath the leather upholstery. The assembly steps are meticulous. The tailor applies glue on the seat padding cushion using a regular paintbrush. He carefully places the high-density cushion and presses it onto the adhesive. He traces vertical cutting marks and horizontal margins before he takes a foam cutting saw to trim the cushion at an angle. Creating a nice curve in the seat maximizes the pilot and passenger's comfort. With another precision hand tool, the tailor polishes the foam before he glues the cushion on the carbon fiber structure. He lines up a guide mark on the cushion with the center of the seat to make sure it's perfectly balanced. He then covers the foam cushion with a fine leather upholstery and repeats the process for the headrest and lower back section of the bespoke leather seat. Back in Modena, Italy, we're about to witness the assembly of the Huayra, a Pagani supercar equipped with an AMG engine, Brembo carbo-ceramic brakes, and MHG oxidized titanium mufflers. Workers assemble the carbo titanium central monocoque on a subframe jig. They bring in the front bonnet, pre-molded with holes for headlamps and aerodynamic flaps. They walk past the central cabin and open up the rear bonnet. It must open and close smoothly, for it will host the car's massive engine. The front subframe comprises the front radiator, the three-stage suspension system, and the wheel hub. A mechanic mounts a carbo-ceramic brake disc on the wheel hub and screws it on. A total of 1,400 custom titanium nuts and bolts are used in the assembly process. The front subframe and the rear subframe rest on custom trolleys, while workers install the central monocoque in between. The front subframe now connects to the cabin, as does the rear subframe. The rear wheel hub is mounted on the suspension arm. The cabin is ready, with wiring and electronic connections in the steering wheel and air conditioning vents integrated in the chassis. A worker checks the fitting of the engine in the chassis. He inserts titanium rear pipes over the exhaust tube. These parts only serve an aesthetic purpose. He bolts them on tightly to the exhaust using a special flexible bolt driver. He then takes a brush tip permanent marker to indicate that the bolts and nuts have been thoroughly tightened. Workers install the car door sill, or brancardo in Italian, made of one single piece of carbon fiber, which closes the side of the car from front to end. Mechanics now mount the wheels. They are equipped with record-setting Pirelli P0 slick tires that were adapted from the Zonda R, as were the forged lightweight rims. The mechanic fastens the titanium wheel lock nut by hand, and with a wrench, tightens the wheel on the hub. Mechanics take the car off the custom-made hydraulic lifts and leave it on an assembly line platform. A worker now mounts the seats, assembling the seating cushion with the adjustable back section. He installs the seatbelt buckle guard and fastens it with a wrench. He brings the assembled seat to the pilot's side door and carefully places it inside the cabin. Workers workers inspect the finished car before it leaves the assembly line. This road-ready car features the classic Pagani quadruple exhaust. It also features gull-wing doors, a back hatch and front hatch. The spacious cabin is coated with top-quality leather from the air conditioning vents to the electronic driving console and glove compartment. A sequential 7-speed transmission puts the driver in complete control of the massive 6-liter, 730-horsepower engine. The front suspension allows the driver to adjust ground clearance, providing the car with a variable drag coefficient. The Huayra is the only car in the world equipped with 4 built-in independent aerodynamic flaps, automatically adjusting the vehicle's aerodynamic ratio.